Hello friends, under this Chem History module, we are going to talk about the periodic table because the UNESCO has decided to celebrate the 150th year of the periodic table. The UNESCO has decided to celebrate 2019 year as the International Year of the Periodic Table of Chemical Elements. We have completed 150 years of the periodic table because the periodic table was provided by Mendeleev way back in 1869. You all know that today we have 118 elements in the periodic table. Discovery of elements in fact has been a very interesting experience, but classification of elements is even more thrilling than the discovery of the elements. Initially, we had very limited knowledge of elements because our knowledge was confined only to those elements of daily life like gold, silver, tin, copper, lead and mercury. The first scientific discovery of an element occurred in 1849 when Henning Brand discovered phosphorus. The father of the periodic table is none other than Mendeleev. His Russian name was Dmitry Ivanovich Mendeleev, but he was more commonly known as Mendeleev. He was very curious about the classification of chemical elements, and for the first time he came up with a very comprehensive system for classifying the chemical elements. He devised a system in 1869, and in that system what he did was that he arranged the known elements in order of increasing atomic mass, which resulted into a table displaying pattern of the properties of those elements. Mendeleev formulated the periodic law, and in fact he created a far sight version of the periodic table of elements. In fact, he used it to correct the properties of some already discovered elements. Mendeleev was also known for making predictions, and interestingly he predicted the properties of 8 such elements which were not discovered at that point in time. And please note that several of Mendeleev's predictions were turned out to be true, and in fact they brought in fame to Mendeleev. According to Mendeleev's periodic law, when the elements are arranged in order of increasing atomic mass, certain sets of properties recur periodically. You can see the Mendeleev's periodic table as shown here on the screen. In Mendeleev's table, elements with similar characteristics fall in vertical columns called groups.
Three, two, one.
Mendeleev's periodic table is an arrangement of the elements that groups similar elements together. Interestingly, Mendeleev left blank spaces for the undiscovered elements like scandium, gallium, germanium and technetium, so that these elements can be grouped together. But at that time Mendeleev did not make any prediction about the noble gases, and therefore he did not leave any spot for them. He realized that there were errors in atomic masses, and because of this he did not place certain elements in order of increasing atomic mass. Like argon with atomic mass of 39.9 was put before potassium with atomic mass of 39.1. So, he placed elements into groups that expressed similar chemical behavior. It is important to note, friends, that Mendeleev was not alone to have arranged the elements. There were a number of scientists who also worked for the classification of elements over a period of about 200 years. Let us know some significant contributors in this chem history module. And I will begin from Antony Lavoisier. In late 1700s, a famous chemist, Antoine Lavoisier, categorized all the known elements by their basic groupings such as gases, metals, non-metals, earths.
Three, two, one.
In 1815, William Prout observed that atomic masses seem to be multiples of that of hydrogen, and accordingly William assigned the atomic masses to the existing elements. In 1829, another interesting development took place when Johann Wolfgang Dauvergne grouped similar elements in group of 3, where the atomic mass of the middle element is the arithmetic mean of the other 2 elements. See the interesting example. I mean, you have lithium on one side with atomic mass of 7, potassium on the other side with an atomic mass of 39, and when you add 7 with 39 and divide it by 2, you get the atomic mass 23, which is that of sodium. Until 1863, only 56 elements were known to us. In fact, new elements at that point in time were being discovered at a rate of approximately 1 element per year. There was a very slow progress. In 1864, John Newland came up with a law of octaves, very interesting law actually. He noted a pattern in the atomic structure of elements with similar chemical properties. In fact, Newland was the first person to devise a periodic table of chemical elements which was arranged in order of their relative atomic masses. Law of octaves stated that any given element will exhibit analogous behavior to the 8th element following it in the table. And using the law of octaves, Newland classified all the 62 known elements at that point in time. And in fact, he showed groups going across the table with periods going down, which is exactly opposite from the modern form of the periodic table.
Three, two, one.
In 1864, Lothar Meyer published a table with 28 elements. He came up with an interesting idea, and according to him, if the atomic masses were plotted against the atomic volumes, the curve obtained a series of maxima and minima the most electropositive elements appearing at the peaks of the curve in the order of their atomic masses. After a gap of 4 years, in 1868, Mayer revised his own table with 55 elements, and like Mendeleev's, he also predicted the discovery of new elements such as germanium, but his concept was not accepted, did not receive favor from other scientists, and his innovation was not recognized by the Society of Chemists until 1887. His draft table was published, unfortunately, only after his demise. In 1869, Mendeleev published his own periodic table. So, let us watch this video on the biography of this great scientist Mendeleev.
Dmitry Mendeleev. He was the inventor of periodic table. He was born in Verkhny Aramsyany, Tobolsk Governorate, Russian Empire on 8 February 1834. His father's name was Ivan Pavlovich Mendeleev, and mother's name was Maria Dmitrievna Mendeleeva. His childhood was marked by tragedy when his father, Ivan Mendeleev, began having health problems. He passed away in 1847, leaving Dmitry's mother to work at a glass factory to support the family. Tragedy struck again in 1848, when the glass factory burned down. The family was forced to move to St. Petersburg. In 1855, Mendeleev was diagnosed with tuberculosis, but he continued to pursue his education to become a teacher. He graduated from the main pedagogical institute in St. Petersburg. In 1855, Mendeleev became a science teacher in Crimea. He soon decided to move back to St. Petersburg and continue his education. A year later, he completed his master's degree in chemistry. He became a professor at the University of St. Petersburg. He realized the great need for an organized and quality chemistry textbook, so he began to research and work on one of his own. In 1861, he released Organic Chemistry, a 500-page textbook. The book went on to win the Damodar Prize and push Mendeleev to fame in the scientific community. In 1867, he was honored with the chair of general chemistry at the University of St. Petersburg. He used his position to push Russia to improve and focus on their understanding of chemistry. In 1869, Mendeleev came out another major book, The Principles of Chemistry. The book became so popular that it was translated to French, German, and English. This British Royal Society gave him this highest honor for his famous scientific discovery, the periodic table. He died in St. Petersburg, Russian Empire, on 2 February 1907, at the age of 72.
Three, two, one.
Friends, Mendeleev is known to have made certain predictions which turned out to be correct. The first of Mendeleev's predictions was confirmed in 1875 when gallium was discovered, which was predicted as Ica aluminium by him. Two more of his predictions were confirmed within another decade. In 1882, both Mayer and Mendeleev received the Davy Medal from the Royal Society in recognition of their outstanding work on the periodic law. Newland, who gave the law of octave, was also given this medal, Davy Medal, for periodic law, but he was given Davy Medal after a gap of 5 years in 1887. It was not until the following century, with Gilbert Lewis' valence bond theory in 1916 and Irving Langmuir's octet theory of chemical bonding in 1919, that the importance of the periodicity of 8 would be accepted.
Three, two, one.
In 1890, William Ramsay and Maurice Travers discovered the first 5 noble gases: helium, neon, argon, krypton and xenon. And in fact, there is an interesting anecdote which I would like to share with you here. Until 1781, we did not know the composition of the atmospheric air. Lord Henry Cavendish carried out the experiment in his lab, and when he was carrying out the experiment, he observed that the entire jar was filled with water, but there remained a small little bubble of 0.5 cc in the corner of the jar. He was quite anxious, very curious to understand that mystery, to resolve that mystery. He repeated that experiment a number of times, but every time he would see that small little bubble in the corner of the jar. He wrote a paper which was published by the Philosophical Magazine, because that was the only journal at that point in time which was publishing the inventions and the research. And he devoted one full paragraph on this mystery of a small little bubble of 0.5 cc. He wrote that I have not been able to resolve this mystery. This is beyond my comprehension, and I am leaving it for the posterity to resolve this mystery. Now look at the humility of that great scientist. Look at the truth. Look at the significance of perseverance, that he carried out that experiment multiple times, and his concern for the humanity. And I am happy to share with you that in the same lab, after a gap of 100 years, in 1881, this great scientist William Ramsay, he discovered that it was an inert gas which was not dissolved in the water. It was argon. I am happy to share with you that Sir William Ramsay, who was a Scottish chemist and who discovered the noble gases, he received the Nobel Prize in Chemistry in 1904 in recognition of his services in the discovery of the inert gaseous elements in air. Following the discovery of the inert gases, Mendeleev improved his periodic table and he added them in the table as group 0 without disturbing the basic concept of the periodic table.
Three, two, one.
let us now try to know some other developments which led to the modifications of Mendeleev's periodic table into modern periodic table. 4 radioactive elements were known in 1900: radium, actinium, thorium and uranium. By 1912, almost 50 different radioactive substances had been found in the decay chain of thorium and uranium. In 1913, Bohr's research on electronic structure led physicists such as Jonas Rydberg to extrapolate the properties of undiscovered elements heavier than uranium. Many agreed that the next noble gas after radon would most likely have the atomic number 118. And now you know that that prediction also turned out to be correct with the discovery of oganesson in 2002 and the name given to it by IUPAC in 2016.
Three, two, one.
In 1913, Frederick Soddy and Kazimierz Fazans found that although these substances emitted different radiations, many of these substances were identical in their chemical characteristics, so shared the same place on the periodic table. And this invention of theirs gave birth to the concept of isotopes. In 1913, amateur Dutch physicist Antonius van den Broek was the first to propose that the atomic number determined the placement of elements in the periodic table. However, Broek did not have any method to experimentally verify the atomic number of elements. It was Moseley who was very keen to test Broek's hypothesis. So, in 1914, Moseley obtained the first accurate measurement of atomic numbers and determined an absolute sequence to the elements, allowing him to restructure the periodic table.
Three, two, one.
Moseley's research immediately resolved discrepancies between atomic mass and chemical properties, where sequencing strictly by atomic mass would result in groups with inconsistent chemical properties. Moseley gave the modern periodic table in 1913 by modifying Mendeleev's periodic table. He gave the modern periodic law, according to which the properties of the elements are periodic functions of their atomic numbers. Henry Moseley classified the elements of the periodic table according to their atomic number instead of atomic masses. But what happened was, unfortunately, that was the time when the First World War broke out and Moseley left his research work at the University of Oxford behind to volunteer for the Royal Engineers of the British Army. So, he went into the battlefield and he was shot and killed during the Battle of Gallipoli on 10th August 1915 at the age of 27. It was a big blow to the scientific community that the scientific community lost such a brilliant brain. Experts, in fact, had speculated that Moseley could otherwise have been awarded the Nobel Prize in Physics in 1916. And as a consequence of it, the British government later on came up with the new policies for determining the eligibility for combat duty because they lost such a brilliant scientist at such a young age.
Three, two, one.
Glenn Theodore Seaborg was an American chemist whose involvement in the synthesis, discovery and investigation of 10 trans-uranium elements earned him a share of the 1951 Nobel Prize in Chemistry. His work in this area also led to his development of the actinide concept and the arrangement of the actinide series in the periodic table of the elements. Seaborg was the principal co-discoverer of 10 elements: plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium and element 106, which while he was still living was named after him as Seaborgium in his honor. You can see this is the periodic table provided by Glenn Seaborg in 1945. There have been many attempts after the modern periodic table like this Adam periodic table of 2006, Harrison spiral periodic table, chemical elements pyramidal diagram, circular form of the periodic table given in 2006, the ring of periodic elements trop given in 2006, alternative circular periodic table given in 2013, the chemical elements and their periodic relationships given in 2016, which was known as curled ribbon periodic table by Hyde.
Three, two, one.
Friends, let us note that none of these alternative periodic tables which I have referred to a little while ago could replace the modern periodic table, the foundation of which lies on the Mendeleev's periodic table, and which is why Mendeleev has been rightly given the title of the father of the periodic table. It is interesting to note that Mendeleev claimed to have envisioned the complete arrangement of the elements in a dream. He said that I saw in a dream a table where all elements fell into place as required, and awakening I immediately wrote it down on a piece of paper, and only at one place did a correction later seem necessary.
The elements of the periodic table. There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the signs, sodium for salty times,
magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table, no gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get, copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine film, while krypton helps light up your room, rubidium, and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun, lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, the bismuth for your tummy,
polonium,
astatine would not be yummy,
radon,
francium will last a little time,
radium,
then actinize at 89. This is the periodic table, noble gas is stable, halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, and olivium, nobelium, lawrencium, rutherfordium, wm, sprigium, boreum, hesium, meitnerium, dubsidium, rucanium, copernicium, natrium, flerovium, pentium, livermorium, septium, noctium, and then we're done.
Ladies and gentlemen, it gives us a message that all of us must be so passionately committed and loyal to our work like these great scientists who even in their dreams think of only their work. Let us celebrate this 150th year of the periodic table in our respective institutions by way of organizing various activities. Thank you very much.
Thank you.